Hi, welcome to the Forest Service WEPP tutorial on ERMiT, the erosion risk management tool. My name is Pete Robichaud. Let's get started. If you want to run ERMiT, you first need to go to the Forest Service WEPP Launchpad. At this site, you have to pick which unit you'd like to run the model in before you get started. So you can click on metric or US customary. Then you click onto the ERMiT button. This brings you to the Launchpad page for ERMiT. The first thing we have to do is to pick a climate. We'll go to custom climate. I'm going to pick a state that I'm interested in. In this case, I'm going to pick Montana. Have it display the climate stations for Montana. Here are all the climate stations. I'll scroll down to Stevensville, Montana. I'm going to say add to personal climates. If we want to modify that with the prism button, we'll talk about that in a separate tutorial. So I'm just going to say add to personal climates. I can use the describe climate so you can see what that will look like. Here's the climate file for Stevensville. Mean precipitation 12 inches, 91 wet days. Okay. I'm going to say return to input screen, add to personal climates. And return to input screen. And there's Stevensville right at the top of the list of my climates. Next item is my soil texture. I have 4 choices on soil texture. And I'm going to pick the sandy loam because that's what I think is in that area that I'm interested in modeling. If I click the question mark, it gives me a description of what those different soil types mean and how you can relate to that. If you have an ash cap soil, as an example, you'd be picking a sandy loam. You close that. If you want to know more about what the input parameters are for WEPP, if you hit the soil texture button, it will tell you what the values are that we use in the input file for WEPP, the hydraulic conductivity, erodibility, etc. All of that's right there so you can see it. The next item is the rock content. This is the rock content in the soil. If you click on this little button, it will tell you that it's the rock content in the soil, not on the surface. I believe that in Montana, we might have about a 12% rock content. The next item is the vegetation type. We have forest, range, and chaparral. On forest, you do not need to fill out what the pre-fire community looks like. But if you pick range or chaparral, you have to say something about that. It has to always add to 100%. So if I think the shrubs are more like 25%, it will ask me, well, how much is that in grass? And I'm going to say 50%, and it will automatically update the bare soil. If I pick forest, you don't have to do that. With chaparral, it's the same thing. You need to determine how much of the cover is from chaparral cover to grass and bare soil. So in this case, I'm going to use forest. I have to describe the hill slope gradient next. This is what it looks like. 80% of the area is going to be what that middle gradient is, 10% at the top, 10% at the toe. So we might have a slope that's at a 50% and it gets a little gentler at the very bottom. The next is the horizontal length. And here it is just showing you again what that length will look like. So in this slope, it's going to be about 800 feet. We have a limit of about 1,000 feet on the hill slope horizontal length. The next item is the soil burn severity class, whether it's going to be a high, moderate, or low, or unburned. If you click the question mark button, it will just remind you that since this is a probabilistic model, that we run the model numerous times for different scenarios of overland flow elements or sections of the hill slope that will have a high and a low burn severity, even if I pick just a high. The purpose of that is because of the variability that's actually out there that we've measured with our different experiments that we've done in the past couple of decades. So with that, we have all the parameters we need. We hit the run button. So ERMiT is now sending the commands to the server. It's running the WEPP model in the background. It's running a bunch of different runs, about 25 different runs, to be able to get the variability in the climate, the soils, and that burn severity. So here's the output screen. It shows you what you had put in for the inputs right at the top. It tells us that in Montana, here's our annual precip, 13 inches at this location, and the amount of runoff that we got from snowmelt and also from rainfall. This table characterizes the ranking of the runoff events. So the rainfall that caused these runoff events. Looks like all of my events were during the summer, okay? So look at this 20-year return interval event, and there I can see my storm runoff amount, my storm precip, the duration, and the 10-minute intensity. So in September, we had a 2.6 inch, 10-minute rainfall intensity storm. Next down here is my probability table of sediment. So for this particular site with those low rainfall amounts, we have a low amount of sediment that's likely to be delivered. So this is a graphical form, and then down here is a tabular form of that untreated condition for years 1 through 5. Each of these different colors are showing that year. Okay, down here at the sediment delivery table, it's interactive. I can change the probabilities that I want to look at. I can put in 40% as an example and watch how it changes. So I would read this, that there's a 40% chance that if I do no treatment, I'm going to get 0.06 tons per acre at the base of that hill slope. If I apply some mulches, you can see how that goes down. If I go to the bigger events that might likely occur, you can see how that number increases, but if I put mulch in this particular case, that decreases. These little print buttons here allow you to look at the tables that we use to calculate the sediment delivery and how we apply the spatial distribution to that. You click on this icon on the right, it will give you the sentences to describe what's going on. There's a 20% chance that sediment will exceed 1.29 tons per acre in the first year following the fire. We did that so you can use that information directly in a report if you're interested in. If I click over here, it gives you another table showing you how we get the probabilities for those particular scenarios that we're looking at. And finally, down here with the erosion barriers, you have to give us some information about the size of the barrier. So this is in feet, so maybe 0.5 feet, and the spacing might be more like 50 feet. And we hit go, and it'll tell us that if we did that, we would have no erosion coming out of that particular combination. So all of this is interactive. You can then return back to the input screen and make some different choices and continuing on. So that's the basics of using ERMiT. Thanks for watching. Hope you enjoyed WEPP in the woods.